Okay, you can see
Yes.
everything. Okay, thank you. And greetings. Thank you. Greetings to all colleagues and professors. So due to lack of the time, I will try to be more concise as I can. So the topic of my today presentation is the traffic intensity and air pollution before and during lockdown in Novi Sad. So first, I will just shortly go to the background and aims. So the urban air pollution by the particulate matters is one of the major and complex issues in the modern world, especially the traffic-related pollution near the roadways, where these concentrations tend to be more severe. Regarding the particulate matter air pollution in Novi Sad, it is often influenced by the individual boilers and furnaces, also intensive traffic in urban areas and thermal power plants, of course, depending on the seasons. So by the appearance of the highly contagious coronavirus, the government had to adopt different levels or interventions and emergency measures. They were actually reflected in the lockdown, traffic reduce, and also the people movement reduction. So the aim of our study was to analyze the relationships between fine and coarse particulate matters with traffic density, but also between these particles and meteorological factors like temperature, pressure, and relative humidity on working days and weekends, and also to calculate the traffic emission contribution to these particles during 2 sampling weeks, first week with regular traffic regime and the 1 week with modified traffic regime, which is also the first week of the introduced emergency measures in Serbia, but now we're talking about the Novi Sad. So the sampling period lasted from the 9th of March to 22nd of March. So we chose the one specific location that was representative traffic site with heterogeneous traffic flow. So all the data we actually were analyzing are collected from the public services. So data about the particles and meteorological parameters are collected from the Serbian Environmental Protection Agency station. The traffic count data are collected from the traffic counters that are under jurisdiction of the public enterprise urbanism. And also we were using the data about the particles from the nearest urban background location in order to calculate that traffic contribution. And this site is under jurisdiction of the City Administration for Environmental Protection. In these 2 pictures, you can see the specific location of those sites and also the distances among them. So the background site, you can see here in the picture 4, you can see that it's surrounded with the residential buildings, small parkings, and also in the vicinity is the river Danube. So about the methodology, we were using the a certain traffic classification. So we were using the categorization that was consisted of the passenger cars, vans, lightweight trucks, and buses. And emission contribution, or the traffic contribution, was calculated by this equation. We were actually subtracting the particle concentrations from the background side from the traffic side particle concentrations. So our results are divided on few sections. First, I will talk about the particulate matter concentration data, then about the traffic count data, and about their relationship and possible comparisons. So in this table 1 and 2, you can see the descriptive statistics for the fine and coarse particulate matter, which are the 24-hour concentration values. And all these values are from the traffic site. So each table is divided on the first and second sampling week. So in this graphic 1 and 2, we have the 6-hour average concentrations. So left side for the PM2.5 and right side for the PM10. So we can see in these lines, the red line in the case of the fine particles and the blue line in the case of the coarse particles, the concentration during the second week, the lockdown week, actually increased during the working days, and especially on the weekend, the morning of Saturday. So better insight we have on this slide. So we have the box plots that actually represent the 1-hour concentrations for fine particulate matters for the first and second sampling week. So from this slide, actually what we can see in the first week, we have these diurnal variations of these fine particulate matters during all this day. But in the second week, if we just compare the working days, we can see more uniform changings in these variations. So we have actually the lowest concentration in typical working hours. So from about 8 a.m. to about 5 p.m. In the case of the weekends, we can see here that in the first week, this concentration, the higher values were also in the same hours like for the working days, but of course in the lower concentration levels. And in the second week, we can see here a lot higher concentrations for about 90 micrograms per cubic meter, and were the highest from the 1 to about 6 a.m. In the case of the PM10, situation is similar. So also we here have, if we just look for the second week, will be easier. So we also have by these mean values, we have higher concentration also in these early morning hours, and then after 6 p.m. Also in the weekends, here also we can see the higher concentration. So these higher concentration, of course, are from that Saturday morning, like we saw from the previous slide. So considering the traffic count data, so on these box plots, we show the total traffic count data. So in the second week, as we assumed it will be, we have the decreasement in traffic volume. So on the working days, that would be about 68.7%, and on the weekdays, about 22%. But as we can see here, the pattern of these higher volumes during the days stayed similar for both these sampling weeks. A little more about data characteristics. So in this table 3 and 4, we have the 24-hour vehicle count data for all mentioned classes per each day. So all our raw data had the 15-minute resolution. So here we can see the most number of classes were for the passenger cars, buses, and the lightweight trucks. So the same situation is also for the second week, but of course in a smaller counts. So all data for easier visualization and to see the share of each class in total traffic, we normalized our values of the vehicles. And so here you can see on the graphic 3 and 4, we have the 6-hour vehicle counts on weekdays, Saturday and Sunday. So these, like we see the passenger vehicle class is the most number. So the highest intensities were from the 7 a.m. to 6 p.m. So it's the similar situation for the Saturday. Sunday is a little bit different. So in the second week, we have the also similar situation, but only on the weekends after 7 p.m. we have here the major decrease in vehicle count, which actually corresponds to those that emergency measures where people couldn't go outside after 8 p.m. So after I showed you these data sets by alone, now we compare this data on this slide. So we have in this graphic 5 also the 6-hour concentration, 6-hour values for the A1C1 vehicles, which represent the left scale, and on the right scale we have the concentrations for these particulate matters. So from this slide we actually can't see that much because this A1 class, it's has a lot higher volumes depending on the other classes, but we can see here that PM2.5 values, concentrations, a little bit following these vehicle count volumes, for example, for the A1 class during the Saturday and Sunday, and for the PM10 as well. But to be more specific, we conducted the correlation analysis between fine and coarse particulate matter for each vehicle class. On the left side, you can see here the correlation graph. So in the first part of the table, we can see the Pearson correlation coefficients and statistical significance. So we actually found that fine particulate matters in this first sampling week were moderately positive, moderately correlated to the passenger vehicles and lightweight trucks, yes. And during the second week, we have also strong and moderate positive correlations with all these types of the vehicles. In the second week, as we all know from the previous slides, we have a lot higher concentration as well. We can see here, based on this slide, on this graphic, we can say that there are no correlation between this data set, which is also confirmed by these results in the table 6. So we can see that we didn't found any positive correlation with fine and coarse particulate matter with any of these vehicle classes. So in order to calculate the traffic contribution, like I said, we were using the particulate matter concentration data. These data from this background site had the only 24-hour resolution. So in this table 7 and 8, you can see the descriptive statistics, and also we placed the TRFsite data for the some comparisons. And in this table 9, we have the 1-hour values of the temperature, pressure, and relative humidity during these 2 sampling weeks. And here we actually gathered all these presented data in this graphic 7 and 8. So here we have on the left side and right side for the first and second sampling week. So here we can look for the background concentration, and we can see that during first and second week, these concentration didn't change that much at all. So if we look to the minimum and maximum values, we actually can see the numbers that these concentration were quite similar. In the case of the meteorological parameters, we can see that, okay, the pressure were at the higher levels, the temperature had lower values. So we can see here the minimum value decreased for about 2 degrees of Celsius, and the maximum values of temperature for 4 degrees of Celsius, and as well the relative humidity decreased. But since the background concentration didn't change during these 2 weeks, we wanted to see, are there any correlations between total traffic and these concentration from the background side in order to calculate the traffic contribution. So we found here the moderate positive correlation between fine and coarse particulate matters with total traffic. So you can see here on the left side these correlation graphs. So the results of our traffic contribution calculation in these tables 11 and 12, yes, we can see that in the second week, I'm just looking for the second week. So the second week, in the case of the PM2.5, we can see that the concentration ranged from the 3 to 48 micrograms per cubic meters, which is a lot higher concentration if we look for the first week. And in the second week, in case of the PM10, we're going in the range from the 5 to 88.3 micrograms per cubic meter. So in this graphic 9, we again just plotted these values of the traffic contribution and also the meteorological parameters to see again that in this second week, we actually have some different source that actually contributes these particulate matter emissions. So we actually, what we done next, we actually more analyze these values by the correlation analysis of these fine and coarse particulate matters from traffic sites and these values for the temperature, pressure, and relative humidity. And what we found, we can see here, table 13 represents the first sampling week. We only found the moderate positive correlation between PM2.5 and relative humidity, and the moderate negative correlation between PM10 and pressure. But in this table 14, we actually can see that in this second week of the lockdown, when we have the highest concentrations of the particles, we found the very strong positive correlation between PM2.5 and temperature, and strong positive correlation between PM10 and the temperature. So as the summary, we have 2 slides. On the first slide, the summary for about these data itself. So actually, what was the conclusion? That particulate matters increased during this second week, the week of the lockdown. Traffic decreased by the 68% on the working days and 22% on the weekdays, which is of course expected and evidence of that impact of the lockdown measures on traffic intensity. Also the concentrations, if we compare, if we compare the first and second week, highest concentration were during working days, and in the second week we have more uniform patterns of these fine and coarse particulate matters during the day. The most numerous categories were passenger cars, buses, and lightweight trucks. Also, beside these total traffic decreasement, we had the similar patterns of traffic counts during both weeks. Considering the vehicle count decreased by their category in the second week on working days, the vehicle class that actually decreased the most in percentages was the trucks, class of the trucks, lightweight trucks and vans, and also, of course, buses. And in the weekends, it was for the lightweight trucks and vans. Considering the summary of our comparisons, actually we found that in the first sampling week, the main or one of the main emission sources of the particulate matters was the traffic, because we found the strong and moderate positive correlation between fine and coarse particulate matters with each these vehicle class in the case of the PM10 and two classes in the case of the PM2.5. In second week, we didn't find any positive correlations between these two data sets. So these correlations were also confirmed by the positive correlation. These are actually the traffic emission as the main source was also confirmed by the positive correlation of the background particulate concentrations with total traffic. So beside this fact and higher concentrations, like I mentioned with the previous slide, these strongly indicated a secondary emission source of particulate matters, which is actually confirmed that this very strong positive correlation that we actually found between fine and coarse particulate matters with temperature during this second week, where the Pearson correlation values were 0.92 and 0.91, confirmed that this lower temperature impacted on particulate matter concentration, and as a consequence increased the impact of heating as emission source during these lockdown measures, and the fact that people staying longer at their homes. So, and of course, we acknowledge the funding by the Ministry of Education, Science and Technological Development in Serbia and Vinci Institute to the grant Horizon 2020 with this project. Also grant agreement under this number, and Ministry of Education, Science and Technological Development in Serbia. Thank you for your time. I hope I didn't talk over 15 minutes.
Thank you, Sonja. It was a very nice case study. I think this shows that the local heating as a source is really important, and when one makes measures, be it changing the fuel base or changing transport or changing basically patterns how people behave, it can have negative consequences. Yes. Even the best meaning measures. So it is always very important, as you have demonstrated, to really look into what is actually happening and to take measures that the air quality is not very much made worse. Yes. We see that in Norway also, but I think this is quite general conclusion and very often very overlooked. So I hope you will publish this result, because I think, but not least, that you will make it available to the decision makers, because they need to understand the linkages between the sources and emissions and what people do and what measures one take and how it all works together. So this was a really nice example.
Thank you. Thank you.
Are there any questions to Sonja? If not, then I will wish you the best, and
thank you, Professor.